Everybody, it's Tyler here. Robot in 30 Hours is underway. We're going to be checking with a couple other fantastic teams coming in from Wisconsin, starting out with team number 16310, Rising Rhinobots. And I'm here to share them and the rest of the team here. Tell us a little bit more about your team, then we're going to be diving more into your robot as well.
Yeah, so this is our third year as an FTC team. We are super excited to embark on the Freight Frenzy Challenge. And with a challenging game this year, hopefully we can perform to the best of our abilities.
So we're going to be hopping into the robot in just a moment, but tell me a little bit about the Freight Frenzy Challenge. When you approached it from a robot in 30 hours perspective, talk to me a little bit about some of your strategy and your how you kind of broke the game down a little bit before you started building.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
First Updates Now is supported by Kettering University. Kettering University is where robotics students come for their education. Over 30% of those who attend Kettering University were in high school robotics, and you can keep going with their BattleBots, VexU, esports, and FIRST mentorship programs. If you are a U.S. student grades 8 through 12, scan the QR code to stay up to date on info and events happening at Kettering and get a free Kettering t-shirt when you sign up by December 12, 2021.
So what we did for the game strategy is that we broke the game into three parts. So autonomous, teleop, and endgame. So what we thought for autonomous is there are many different ways to score in this year's game compared to last year's game. So we thought of different ways to score points. So some things we did for autonomous is we were thinking of using a motor for our carousel to spin the carousel counterclockwise in order to get to the duck onto the field. And another thing that we're planning on doing in autonomous is also parking on the warehouse, so making the robot go forward. And for the teleop period, we were thinking of just using our arm on two ends in order to put the freights on our alliance hub. That will score 4 points for each time we do it in 90 minutes. And for endgame, we were planning on putting freights into the alliance sharing hub, into the sharing hub at the end of the field in order to tip it to our side, as well as putting our custom element onto the top of the tip for our sharing hub in order to score 15 bonus points.
Well, we can only have the robot off screen a little bit for so long, so let's bring the robot kind of front and center and start to break down some of the different mechanisms and assemblies that you've done so far, and then we'll ask some questions as we go through. And Chad, if you're watching live, you're welcome to ask any questions for Rising Rhinobots as well.
So, hello, I'm Derek. Let's start from the bottom. We took a standard strafer chassis that we had pre-built before the season started, and we modified the wheels because Meccano wheels aren't that great for this year's season, which is surprising. So we just took regular hard drive wheels and tried to see if they could jump over the black bar into the warehouse. They did not. They did not have enough clearance. So in the end, we just padded them with a lot of foam and a lot of duct tape. And that is our drivetrain.
Let me ask you as a follow-up to that, you talked about how Meccano wheels you believe aren't that great. Did you do any testing for that, or is it just something you saw, you're like, I don't think this would be a good fit?
Well, we did do testing. We tried to see if they could hop over the black bar, and the ones we got were just really small. We didn't have any 6-inch Meccano wheels
Sure.
that would fit onto the frame.
Makes a lot of sense on that. So what is actually the material that's on the wheels currently?
Foam padding and duct tape.
All right, fair enough. Duct tape solves all problems, all right? So very cool on that. Keep walking us through. Talk to us a little bit more about some different components and mechanisms. And then for the drive itself, what are you using for motors, that sort of thing?
These are just, I can't remember the exact name of them, but they came with the strafer chassis kit that we bought last year.
Sure.
So there's some kind of go build a motors. I can't give any detail on that right now. I'm sorry.
That's all right. Take us through some of the other assemblies that you have.
Right. So over here we just have a gecko wheel on a standard motor, and that's to spin the carousel, and it works really, really well because it's just a mounted motor. You can't go wrong with a mounted motor. For our intake, we have these rubber fingers, I guess you could call them. They work exceptionally well because they pick up all objects regardless of how heavy or the size. They work really well on the circular ones because it's not like a claw where, if you ever try to pinch a grape, it kind of slips and slides. Well, if you just scoop up the grape, then there's no need to pinch it in the first place. And from there, it goes into this arm system, which, thanks to the power of gravity, always points straight down. So we don't have to worry about weird angles or something like that. And it's a little bit hard to see. The last bit of hardware, I guess you could call it, is just a plate here to make sure that every time this arm comes down, it always lands in the same spot.
So let's unpack some of this a little bit. I'm very interested to hear about this two-stage system that you have essentially, right? So, so a piece comes through. How do you potentially prevent like multiple pieces from being coming into your robot? And then how did you come up with the whole kind of this carriage lift type system as well?
So, sorry, just let's break down the first part, preventing multiple pieces. We don't have like a hardware system for that yet, although I will say that sometimes they just don't go very far up, so there's quite a bit of like time for the driver to stop the intake if they see their two pieces traveling up at the same time. And sorry, what was the second question?
So how'd you come up with the concept of like having that second transfer part where it's gravity, just held by gravity essentially? That's it's something that I'd be interested to see like it perform once we see some videos come out of your robot as well. But just curious on how you came up with that general concept.
This was an idea I had actually tackled all the way back in the Skystone season when we were stacking bricks. And this was it looked a lot easier, and also there's another team building around us, and they beat me to it. They built the idea first, and I saw that it worked well. So I was like, let me get a bunch of guys together and let's all build our own version. And it worked well.
Yeah, fair enough on that. Talking about your carousel mechanism, obviously simple works best in many cases for that. What kind of testing did you do to, like, with having the ducks on the carousel? Like, did you try going at certain speeds or anything like that? Or how did you determine, like, how quickly you could actually spin that gecko wheel?
Yeah, we actually did a lot of trials for that. So when we placed the motor against the carousel, at first we put it at a speed of 0.4, and we realized it was too fast, so we decreased it to 0.3 and then 0.2. We realized 0.2 was a little slow, but the duck landed on the field like perfectly. It was at the perfect, precise moment. It was a little slow, but I mean, I guess you got to play it safe. So we took a lot of tests for that, and we realized if we just place the motor against the carousel and go at a reverse speed, it'll go counterclockwise, and the duck will land perfectly on the field. So that's how we did testing for that.
Sure. Are there any other mechanisms that you wanted to go over or cover on your robot at all?
As of now, I feel like that we covered pretty much all that we need to cover.
So, as a kind of a wrap up here, you've been working really hard the last, around 30 hours on this. What advice do you have for teams? What have you learned that you're going to take into this upcoming season with this robot? How do you apply what was done here for the rest of the season?
You can never test too many times. Even if you think like that's enough, we'll stop now. No. The more you test, the more mistakes you'll find. And the less mistakes you have, the better your robot will be.
And as the last follow-up to that, what are maybe a couple of the mistakes that you found as you were creating this robot?
Actually, I talked about this. There's a plate here. This wasn't there before, and the problem we were encountering was, as this comes down, as you can see it, maybe in the camera, it swings, and it would land at awkward angles, which, isn't great when you're trying to have consistency. So the plate just helps reduce the swinging and helps align us in the right spot so we can keep the game pieces moving throughout the robot constantly.
Well, Rising Rhinobots, thank you so much for taking the time to show off your Robot in 30 Hours robot. It looks fantastic. Looking forward to some more videos coming out for that, and can't wait to see, of course, from a competition going in the Freight Frenzy as well. Good luck the rest of the season, and we can't wait to see more of you.
Thank you so much for having us.
Thanks to Kettering University for their support of this video. Kettering University is the leader in new programs of expertise, including artificial intelligence, cybersecurity, and automotive engineering design. If you are a U.S. student grades 8 through 12, scan the QR code to stay up to date on info and events happening at Kettering and get a free Kettering t-shirt when you sign up by December 12, 2021. Thank you to AndyMark, GoBuilda, and Rev Robotics for providing components and giveaways to the Bulldogs Robot in 30 Hours team. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.